Hi, good morning. So, in the last class, we have discussed about how to prepare a glucose by two methods from starch as well as from the sucrose, right? So, after this, there is a one more very important part of this chapter, and from this part, one we can expect questions for your main exam as well as for your competitive exam also, right? This is very important part today. What I am dealing in this class, that is very important. So the next point of this is structure of glucose. So structure of glucose. So we will see in detail about the structure. I mean, the structure is like this. See, CHO, CH2OH, OH, H, OH, H. So alternately, where there is a H, you put OH. So this is the trick. OH, OH means H, alternately. So this is nothing but the a partial structure of glucose. So in this part, what we are going to study is nothing but if it is a structure, then what will be the conformations, right? We want confirmatory tests, right? So that means I'm saying that there is a aldehydic group, there is a CH2OH group, there are 6 carbon in the glucose. Then what is the reason why we are saying the structure of glucose is like this only? So for that, we study about what structure of glucose. That means in the structure of glucose, what all we are seeing over here, they are correct or not, right? By doing some different tests, right? So the first point in this is, so the glucose, the molecular formula of glucose is, first point is, the molecular formula of glucose is C6H12O6, right? So this is the first point in our what structure of glucose. That means after completing all these studies, what all we require for the confirmation of molecular formula, after doing all those I mean experiments, the final conclusion is that the glucose is having the molecular formula like C6H12O6, right? This is the first point. Number two, see, when glucose is heated with hydrogen iodide, when glucose is, I mean, prolonged heating, that means for more time, heat, when glucose is heated with hydrogen iodide, it gives, it gives or it forms N hexane. N hexane. So this point will not stop here itself, right? Next point, that means the formation of N-hexane, what does it indicate in the structure of glucose? That is, we need to study. The formation of N-hexane after reacting with hydrogen iodide, right? So when we are taking this glucose with the hydrogen iodide, then definitely what we are getting N-hexane. What does it indicate? That means the question how they will ask in your exam is nothing but formation of N-hexane indicates with reaction with hydrogen iodide indicates what, right? So first type of question. So it indicates, that means the complete sentence. We will complete the sentence. Full stop. It indicates the formation of N-hexane indicates 6 carbon atom present in the glucose. 6 carbon atom present in glucose. Right? Very important. The question was what with respect to till here formation of glucose when it reacts with hydrogen iodide it forms an enzyme. This reaction indicates what? That is the first type of question. If they twist the question like this, one more type of question on the same sentence. So how do you confirm the presence of 6 carbon atom in the glucose? How do you confirm 6 carbon atom present in the glucose? That means you have to write this. When the glucose is reacted with hydrogen iodide, it forms an enzyme that indicates the presence of 6 carbon atom in the glucose. Right? So these are the two type of questions they might ask, and definitely they will ask. Right? So if you go for the reaction, see CHO, CHOH, there are 4 types. That means 4 carbons are there, and finally CH2OH. This is our glucose. When this glucose is heated with hydrogen iodide for a long time, then definitely we will get CH3, CH2, 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 and CH3. A single chain, right? Because of shortage of space place, I have written like this. It is nothing but n hexane, right? It is a single chain, right? So this CH3 you can write continuously, right? So now this is the reaction. If they ask you to write or to show reaction also, you have to give the answer and then you have to write this reaction also. So that's why please go through this part very correctly, right? This is about first point. That means how do you confirm the presence of 6 carbon atom in the glucose is nothing but we want to react the glucose with what? Hydrogen iodide. If it forms an hexane, then definitely that formation of an hexane itself indicates the presence of what? 6 carbon atom, and you have to write the reaction also. Right? So this is about the second point. In the third point, right? In the third point, hydroxylamine. I mean, glucose is treated with treated with glucose. I'm not writing correct sentence. Just I am giving the hint. Glucose is treated with hydroxylamine. That means NH2OH. Hydroxylamine. Treated with hydroxylamine, it forms oxime. What is oxime? We will see. It forms oxime. It indicates the presence of, that means formation of oxime indicates the presence of carbonyl group. Very important. Carbonyl group. So the question on this, character, this point, they ask like this. How do you confirm the presence of carbonyl group in the what? Glucose. That means your answer should be like this. Glucose, when we treat it with the hydroxylamine, it forms oxime. And that formation of oxime itself indicates what? Presence of carbonyl group. So you just remember this point. I will introduce you what is carbonyl group. Right? This is very important. We have carboxylic acid, aldehyde, ketone, and carboxylic acid. In that also, this part, carbonyl part is very important. But that chapter is not still completed. So I will just give a hint about the carbonyl group. Right? So carbonyl group means like this. This is called a carbonyl group. right? So if this is a carbonyl group, then in aldehyde, ketone, as well as in the carboxylic acid, right? In aldehyde, ketone, as well as in the carboxylic acid, this group, I mean carbonyl group is common, right? Understood? Clearly, you try to understand this point. Carbonyl group is common in aldehyde, ketone, and in carboxylic acid, right? I'm just going in detail now. So, if R is present, I mean methyl group with one hydrogen, then this is called a aldehyde. What? One side should be a R group, or else in case of aldehyde, it may also be a H, that is called formaldehyde, HCOH, right? HCOH. In first year, I already explained this. HCOH, or else CH3CHO, or this you can say CHO. That means clearly you can say aldehyde, right? Like this. HCHO is nothing but formaldehyde. In case of aldehyde, it may be R or H, both the side. If HH are there or else RH is there, then definitely the compound is called what? Aldehyde. So coming to ketone, if both the side R group, I mean methyl groups are present, methyl is nothing, not only methyl, ethyl, propyl, butyl, whatever it may be, but there should be an R group. If R group is attached alternately with this carbonyl group, then it is called what? Ketone, right? So if both are R, then it is called ketone. And now what about the carboxylic acid? Means this group is again common. If it is having a OH group with this, then it is called a carboxylic acid. RCOOH, that's why we call acids, right? So if it is OH at this, I mean right side, then carboxylic acid. If both the side they are having RR, then it is called ketone. If both the side HH or RH is nothing but what? Aldehyde, right? So now coming to here, the carbonyl group is present. The formation of oxime, what it is indicating? It is indicating that there is a presence of what? Carbonyl group. So that means we can understand that formation of oxime is indicating the presence of what? Carbonyl group. But in the next what character, we will see what type of carbonyl group it is. But now in the third point, what we are just confirming that there is a presence of carbonyl group, right? Later we will again one more, I mean when we react glucose with the bromine water, then definitely it forms gluconic acid. That gluconic acid confirms the presence of aldehydic carbonyl group, right? Aldehydic carbonyl group. So for this, we have very clear, I mean, depth study about the carbonyl group during aldehyde and ketone. I will explain it. And this is very easiest part one I can say. So now see here, CHO, shall I write like this? CH, I mean open structure, CHOH 4 times, shortcut we will write, and CH2OH. What we are doing? We are reacting it with hydroxyl amine. So that means NH2, for your understanding purpose, I am writing like this, OH, hydroxyl amine. So now, and carbonyl reactions are very easy. One we can very easily understand these reactions. So H2O will be removed. So now what is left? So C, H as it is. We didn't did anything to the H. So now double bond as it is. And now which group is introducing? NOH. This is called oxime, right? C double bond CH double bond, you know, NOH is nothing but what? Oxime. This oxime itself indicates, if it forms an oxime, it indicates what? Presence of carbonyl group, right? So this is our reaction for third point. So definitely water will be removed, and later what is left in the reaction we just do, right? So this is called oxime one, we can say, with respect to this oxime. So for many organic compounds we don't have particular names, right? So that means there is a formation of oxime which indicates the presence of carbonyl group, right? So next one more character we will see, and one more point we will see. So fourth one, so carbonyl group we understood. Then I said carbonyl group may be what type? It may be aldehyde, it may be ketone, or it may be what? It may be aldehyde, it may be ketone, or it may be carboxylic acid. So now, which carbonyl group is present, we need to know in the next point. So when I react this glucose with the bromine water, next point, glucose with bromine water, Br2 water, then it gives gluconic acid. Gluconic acid. So the formation of gluconic acid itself indicates what? The presence of carbonyl group as a aldehyde group. It indicates carbonyl group as aldehyde group. That means carbonyl group is there, right? Aldehyde group. Aldehyde group. Sure, carbonyl group is there, but it is present as a aldehyde, right? In the form of aldehyde, CHO, one we can say, right? So aldehyde carbonyl group. So for this, we'll see a reaction. So again, the question will be like, formation of gluconic acid, what does it indicate? It indicates what? Presence of carbonyl group. Again, it confirms the presence of carbonyl group, but that carbonyl group is as a aldehydic group. And this test one you can do again with the hydrogen cyanide also. In book they have given, you just go through it. So now see, if I react bromine water, sorry, for confirmation of what in the last point, confirmation of carbonyl group, when you can do that test with not only with the hydroxylamine, you can do it with the hydrogen cyanide also, right? So if I react glucose CHOH 4 times CH2OH, this is our glucose. This glucose, if I react this glucose with the bromine water, then definitely it forms a gluconic acid. That means this becomes COOH, and bromine is a oxidizing agent. That means it will introduce the oxygen into the aldehyde. So now CHOH as it is, OH 4 times CH2OH. This is called a gluconic acid. And this presence of gluconic acid indicates that what? There is a carbonyl group which is in the form of what? Aldehyde, right? So this is all about today's class. In the next class, we will discuss some more 2 points, and then we will confirm the structure of glucose, right? Thank you.